You are.
Oh, yeah.
Okay.
Oh, beautiful. Okay,
Great.
just in time, really. Thank you. There's always huge demand for these workshops, Rich, and so
Oh, yeah.
the recording is something that gets watched, definitely.
Oh, yeah. As I always say, always record.
Okay,
Always record.
that's great.
Yeah.
I don't know what numbers you were anticipating. Did we give you a clue how many people registered with you?
I think it was about 100, but
yeah, that sounds about right. So how many have we got at the moment? We've got about 40.
Yeah.
Okay.
Yeah, well, I'll keep this sort of like on the intro, like not even the intro, kind of like the workshop contents page for a bit. And I'll just go through this because it's pretty non-essential.
Okay,
and this
great.
this will buy us some time.
Okay, thank you.
So essentially what I'll do is I'll go through each of these RMD files over the 3-hour period. Oh, important to know is I know this is a 3-hour workshop, but the main material is sort of like front loaded in the first 2 hours. If you somehow have to go in the last hour, that's fine. You'll be getting like a lot of knowledge just in the first 2 hours. So don't worry too much if you have to go, because it's gonna be quite late anyways. So the first thing will be sort of like learning how to create a table in GT, like what that means.
PP plots
and
to look.
Get a bit of noise on the line. Okay. And then I'll get into like how to create modified parts of a table, because tables have parts. You want to either add them, change them, as many as you want. So this is the way to sort of build up a table and add structure to a table. So that's in part 2 or module 2. In module 3, I'll be about formatting data. So you have values and cells, which are numeric. They may be text. They may be dates and times. This will be about transforming those raw values into a format that you want. It's kind of like in Excel when you're formatting cells. It's the same concept entirely. Part 4 will be modifying columns. So these are like wholesale modifications of columns. It might be moving them around to the position you want them to be in. It might be things like merging 2 columns together in a special way. So that's what this module is about, module 4. In module 5, we'll be getting into summaries. We can actually add rows of data, new data. Typically, the data comes in is a table, like a data frame or a table, as it were, with some data. But you can actually generate summary data in GT. This is like the only function or set of functions where you can actually do that. And so it's a bit of a tough nut to crack in terms of like the functions used, but once we have some examples in our head, it becomes a bit easier and it's pretty powerful. And finally, in the last module, 6, we'll go into like table option functions. And so these are short form ways to access options for a table, which could give it a radical look, change things around, make things convenient for you. So you don't have to dig around into like one particular function, which has dozens and dozens of different arguments. So that's that. That's the synopsis. So the breakdown for this. Are we achieving critical mass here we got 43? Looks like it's stabilizing. So I might just go ahead to the first module here. Okay, so in module 1, let's create a table, that RMD file. It's all about getting a data frame or a table and making that first table. So all GT tables begin with a call to the GT function. Makes some sense. ggplot has a ggplot function to start off, to enter, and GT likewise has the GT function. Has quite a few options at the beginning. We'll go through a bunch of those. But the main idea is that you want to use GT every single time you want to make a GT table. We'll go through 2 other functions, GT preview, which is kind of like a function just to preview some data. I'll show you that quickly as we move on. And GT save, it's all about exporting your GT table to various formats. Okay, so that's GT save. And we'll just do 3 functions in this first module. It'll be pretty light, but also it's pretty important because it's the first main function of the package. Okay, so what I do in these RMD files is I introduce each function with the name and also the short description. And I also give you all the different arguments which are in are for the function and their defaults. Okay, so the important thing is data here is going to be your data frame in GT. And that's the only thing required. The rest are sort of like they already have filled in options here. And we can change them, and we will change them as we go through this. Okay, so you're probably thinking, what data sets can we use? Well, anything that you have is a Tibble, but also the GT package contains a few data sets just to have something to tabulate. They range in size from huge data sets like Pizza Place, which has 50,000 rows. SP500 likewise has about 50,000 rows. This has probably 20,000 of them. But this one right here, we'll use quite a bit, Exibble. It's an example Tibble. And it only contains like a few rows and columns, which is great for examples. You can fit it all on one screen. You can see the entire extent of it. I'll just run this. And this is the table as it appears. It's only 8 rows, 9 columns. It's perfect. And it has a bunch of different data types and other things which make it good to exercise all the different examples in GT. So we'll use this quite a lot. And we'll also use cut down versions of these other data sets as well. Okay, great. So for those just joining, I'm just working on the very first function of the package, which is GT. And so you haven't missed much if you just joined in, don't worry. Basically just taking one of the data sets, which is in GT, Exibble, piping it with a pipe operator to GT, the main function that you need. I'm just going to run that. And we get this HTML table. By default, in RMD files in the preview, you get this HTML preview, which either goes here, well, it's inline here, or you can also do it in the viewer. That's where it appears if you run it in the console. Okay, so this is Exibble as a GT table, the most basic table you can have. Okay, so its basic layout contains column labels and body cells. So these are the column labels, these are the body cells. This is important vernacular that will be used all throughout the package and this workshop. The numbers they're formatted, but they're minimally formatted. They're just put through the format function in R. So you still get like this sort of like notation here. And of course we can change all that with formatted functions, which we'll get to in 2 modules from now. Okay. What you can do more? You can also add a stub. So a stub is sort of a weird name, but it appears on the left side. It's just a special column that contains row names, row labels, or names. So to create the stub, we can actually supply the name of a column that we like to use as the stub. And that'll just be sort of shoved into the stub. So we have this row column right here. It has these labels, row 1, row 2, row 3, so on and so forth. We can put that to the stub by using row name call in the GT function. Okay, so let's do that. So we can see here, now we have that column, it's gone. There's no header above it. There's no column label. It's now on the left side. There's a dividing line here. That's just by default. You can change all that too. But that's the stub. There's nothing above it, but you can insert a label here. That's going to be later. There's a function just for that. But for now, it appears on the left side. This is the stub. So they're like row labels. Okay, so you can do that. And we also have another column here called group. And we have some rows in group A and several more in group B. So this is not there by accident. It's so we can divide certain rows into groups. So row groups, well, it's better to show you than it is to explain it. What you would do is you provide a group name call as, that has the labels, sort of like the IDs for the groups. And yeah, and we just apply the column. So let's do both of these things, row name call and group name call. And see right away, now we have an extra row that has the row group label. And essentially it has rows 1 to 4 in group A. That's, as you recall, we had a column which had group A's for these rows. And then likewise for group B. So they're gathered into like these row groups, which is kind of nice. You can do things with this, like change the label. You could style this, change the lines. It's a way to add structure to your rows. So importantly, you might have like some table which has, you didn't sort it, you didn't arrange by like, the different groups. You might have a table like this where you have group A and group B sort of mixed all the way down. But GT will actually be a little bit smart about this. It will actually put the appropriate rows in contiguous groups, preserving order. So if you do this, we start with group B only because the first row had a group B in that shuffled set of rows, but they're all together. There's no group B and group A sort of scattered down, repeated. It's one group B, one group A in the order that they appear. So that's kind of cool. It'll do that for you. Also, if you use R long enough, you know about MT-cars, and it's sort of I don't think it's a strange data set, but it's one of those data sets which has row names. And if you just scroll to the top and you look at the data set, the row names are the cars, like the car names. It's not there's no column header above it. These are essentially row names. And table doesn't really have those. It's a bit different, but we still support row names in GT. You could do this if you wanted to, and use the row names to stub argument, set that to true. And if you actually do have row names, it'll just put those row names in the stub like that. So it's the same as doing the long form, which is, well, if you did do this, you wouldn't get those. Essentially, it follows dplyr semantics where the row names are essentially clipped out. But in this case, it preserves them. So that's what row names to stub does. Okay. So if you know dplyr, you probably know the group by function. Allows you to get groups. If you run just this, we see now in this printout, we get groups, group 2, saying we have grouped data. Okay, so you're grouped by the group column. What you can do is you can avoid using group name call and just insert that group data into GT. And it'll know, just because it has group data, that we're going to use those groups right there. So this is the same as not using this line and using group name call equal to group. Okay, great. So the power of this is you have multiple columns which are grouped. Okay, say for instance, we have this pizza place data set. I'll show it to you what it looks like. Nearly 50,000 rows. We're going to filter down some of that to this. So we have many less rows, only 18 rows in the end. And now we have two groups, type and size. We can use, we can pass that into GT and use this row group sep argument to have a separator between the groups, because what it'll do is it'll flatten down the groups into like single groups of like flattened names. A little hard to explain, but easier to show. So we see here that the supreme large combination has, it's flattened down, and it has this separator between the different group names, and so on and so forth. We can just keep going down, and that's sort of the usefulness of using grouped data. You can have multiple groups. Okay, so that's everything important about the GT function in GT. We'll get to another function here, which I'll probably use less because it's kind of like a single use function. It's just meant to show you a data set in sort of like a small compact display, kind of like dplyr's glimpse, but in a tabular form. So this one's called GT preview. You pass in your data. Again, it's a data frame, just as before. In this case, you're specifying, these are defaults for the head and the tail. And you can choose whether to include row names or not on the left side. Sorry, row numbers, that is. So let's show this to you. GT cars, that's a data set in GT, 47 rows. We can make that a bit narrower, just with 3 columns. And we'll pass all that into GT preview. And we see here, we get very compact display of 5 of the head rows and the last row, which is the tail row. And we sort of get an indication of how many rows are in between with this and this sort of like ellipsis row. And that's about it. GT preview just allows you to see huge data sets quickly, the beginning and end, you can modify, how many rows you see in the end or the beginning. And you can choose also to exclude the row numbers just to have this. Okay, maybe something that you won't use too often, but it's there just in case you need it. Okay, GT save. First of all, any questions from anybody at all? Okay, always throw them in the chat if you have any. But we'll just move on. And a function which is kind of important, we're skipping ahead to exporting because it's pretty important. There's the GT save function that allows you to do that. And it allows export to a number of different files and image formats. So let's say we start off with this table right here. It's just this right here. Great. So that's a GT table object. Now we want to save that. So we're going to pass that into GT save. And the way it saves is you just give it a file name and it recognizes the extension. And there's only a few extensions that it recognizes, but that's the key way of specifying what type of file you want. So if you specify this as .html, it'll save it as HTML, as an HTML file. So I'm going to talk a bit about this inline CSS thing. It's really complicated in terms of why is this here and what does it do. The only key thing to know is if you're using the Blastula package and you want to include the table as part of an HTML email, which is kind of nice, sending an email, you got some like table in there and you want it to show up and look nice. You can do that. You just have to make sure you use inline CSS equals true because email requires inline CSS. It's kind of strange. If you have it to false and you send an email with that bit of HTML in it, it'll just look terrible. So that's important. And there's an example of this, which I unfortunately didn't have a link for here, but I will make sure during one of the breaks to include an example of how you can send a table in email using Blastula. Okay, so that's definitely a part of that. Okay, if you want an RTF file, say you want a table, you want to open it up in Word, you would just use the .rtf extension in the file name right here. And these files are actually, they exist right here. You can open them up and look at them. If I were to click on this, it wouldn't work for some strange reason because the download kind of fails on cloud. But if you were to actually download these and then open up separately, they would work just fine. A PNG file, so a screenshot of the HTML table, looks pretty good. It's cropped to this, to the actual table itself. You can put it into a presentation. It looks pretty good. So that's one thing you can do right there. You can also save this as a PDF file, which is the same as a PNG. It looks the same, except it takes up a few pages. And it's not cropped to the actual table itself, like the boundaries of the table. But that's possible if you use the PDF extension. If you want a LaTeX table fragment, say you wanted to have a table, but you didn't necessarily want to do it like all in like R Markdown. You want to put into like, say, an overleaf or some other LaTeX file. You can take away the just the table fragment, the table part with the LTX extension and then get a file there. Unfortunately, CSV, well, CSV is kind of like almost the same as your input data. You might be rearranging things. So we really don't do a CSV. XLSX, we're working on that. We want to support all the Office formats soon. So right now, your closest thing to Excel, unfortunately, is opening up in Word and then copying that into like Excel. Yeah, so that's the answer to that. Not yet. Okay, so LaTeX. The important thing to know is like this has a few dependencies. If you're using LaTeX, you can get those just by using this function right here. This will just say, I can just run this in the console. There's a few packages you need to have. Basically, you need to use AMS Math, book tabs, caption, long table. If you're using LaTeX, then you know about that. If you're not using it, you probably don't know what this is. But yeah, so that's that. So those are different output formats you can export to. So the key takeaways of this module, very short, because it's just a few functions. Want to make a GT table, get your input table in close to the right form, and then use a GT function to get it into a GT table. And then you can do much more beyond that. But if you want the simplest table, that would probably be the end of it. The GT function has options for adding group rows in a stub. If you want a quick preview of a table, why not try GT preview? It's pretty good. I mean, I often forget it's there, but it's not bad. If you want to save a GT table to a file, GT save is your friend in that case. Just name your file in the format. And if you get the format wrong, like the extension wrong, it'll just tell you that it's wrong. These are the extensions we support. Okay, so that's that. How does GT compare to Cable Extra? Well, I was looking at it not too long ago, and GT Extra appears to be quite a bit better on the LaTeX side. Supports many more styling options. Cable Extra is a bit more manual in that you have to specify exactly where things go. Footnote support, it's there in Cable Extra, but again, it's manual. You have to, it's not sort of like automated in a way. You'll see that as it comes up here, what footnotes can do in GT, but it's a bit different. So GT is a bit more high level. You give it instructions, and then GT will go through like a build pipeline internally and give you the table that you want. It'll sort of like reconcile a bunch of things because some things may conflict with each other, and GT tries its best to sort of solve that in a sensible way. Whereas Cable Extra, each function is kind of like changes the output table right away. At least that's how I sort of like saw it. So it's basically a difference between a manual, sort of like each function changes the table, compared to like a sort of like a high level thing where each function's instructions, and then later on we resolve those instructions. Great. So that is module 1. I don't think I'll take a break because I'll just go to module 2. And then after this, we'll take a break because this is a bit heavy on the stuff that is GT. So let's start with what we're doing here. So this is all about the tab functions in GT. So they all start with tab underscore. And what they do is typically they add parts to a table, or they modify parts which are already there. Or do things like add footnotes, which does add a part, the footer section. And you can add source notes, which also creates a footer section if it's not already there. Okay, and you can do things like style cells or different locations. So you can style everything. You can style the header, the footnotes, the stub, column labels, spanners, anything that is there could be styled. And options, this is just like a giant gargantuan function in that it has tons and tons of options. We'll skim through them and I'll show you some of the more important ones. But yeah, it's just a lot of options. But it's better that they're there than not there, I suppose. Okay, and throughout this module, we'll make use of lots of different helpers for selecting columns. These are familiar if you use dplyr. These are select helpers, things like contains, matches, starts with, ends with, everything. These are just ways to specify columns. Okay, so that's that. There's helpers for transforming text. If you're going to add text, you can use these helpers to state what the text should be or how it should be transformed. So if you use MD, that's markdown. You put some markdown string inside, and that markdown will be translated to HTML. It'll be translated to LaTeX, to RTF, which is nice. If you use HTML, then you're probably going to have an HTML table in the end, but you can put any arbitrary HTML you want in, like tags and other crazy things like that. Okay. Then there's quite a few of these cells functions. These are for specifying a location that you want to target, either for a footnote or for a cell style. So there's so many because there's so many different locations. But each of these has a sort of optimized interface for, or I guess you can say arguments for accessing the different elements within these locations. So more on that in a bit. This will all become clear as we go through to the examples. Finally, there's some helpers for defining the styles themselves. There's 3: cell text for defining some text properties, cell fill for the fill properties of any cell, and cell borders for defining borders around the cell. Okay, so let's go with the simplest one, I think, which we tab header. This allows you to add a table header. And this is just a title and a subtitle for the table. Okay, subtitle is optional. Title is required. So let's take a look at a before and after table here. This is a GT table based on GT cars. That's a little bit cut down in size. So just this. So now we can also we can use tab header to add a title and subtitle. So let's run this. Okay, great. So now we have this right here. And we used MD because we wanted to use markdown text inside of this. So yeah, markdown right there. 2 asterisks on each side of GT cars makes it bold. A back tick on each side of GT cars here in the subtitle renders it in a code font right there. So that's kind of neat. You can do all sorts of things. You can do this and, sorry, it skips ahead. 1 asterisk on each side is italics. You can do other things too, like create lists and other more complicated things. Basically just any markdown you can throw at it, it will render. So that is tab header with the MD function for the new text. Okay, tab subhead, this is a function which just has a label. So you may recall, I'll just skip down to this. You may recall that there's, when you create a stub, you have like this empty area on the top left. That's actually the stub head because it appears above the stub. We can inject some text here. So let's do car. Let's put car in there. Okay, so now car appears. And we can do the same sort of thing. We can use MD here and make this bold like so. Scroll up. And there we have it. So that's just a single function for putting something in the stub head. So the stub head's kind of a wild card. You can do whatever you want with it. You can define the columns, you can define the rows, maybe both. Have nothing there, totally up to you. But it's there if you need it. Okay, tab spanner. This is a much more important one in terms of doing stuff to the column labels. This allows you to put labels above column labels, so spanner labels, really. So the way you do it is you have a label, the label you want to put above those columns. Some group of the columns themselves. This could be a vector in C. You can use just bare names, or you can use the names in quotes, or you can use one of the tie select expressions, these select helpers. Okay, so let's try that. Triple, okay, I'm looking at the questions here. Would triple star be both bold and italics? Let's find out. I actually don't think so, because under the hood, we're using common mark. So this is actually the common mark specification. So let's see if this works. I highly doubt it, actually. Whoa, okay, it did work. I was wrong. It was a bet. But yeah, you can do that. And if you don't want to do that, you can always do this. I hope works. But it's good to see that it's flexible and it does work. I wasn't sure, because this is different than R Markdown. So this is an important thing to note. You can't actually do some things which are in R Markdown. It uses a different Markdown parser. So things like, I believe it does things like subscripts and superscripts, which are actually not available here. I think it's with this, if I'm even correct about this. And this is totally wrong anyways. But anyways, I think you can't do this. It follows just the common mark specification. But yeah, good question. Glad to see that triple asterisk does work. Can you justify cells? Yes, you can. The header and the subdata looks like they're not. They are aligned the same. Yeah, so let's bring this back. Yeah, they have a different, there's basically an indentation here, and this is left. So we can change all that with tab style, and I'll show you that shortly. It's actually in this module. Okay, so getting back to tab spanner, let's make a small version of GT cars. So I'm going to show that to you. So in this case, there's only 8 rows, which is kind of nice. We can fit it onto a page. Now let's look at the table in GT. Great. There's that. So we have these columns, and we want to have a spanner above one of them or a few of them. So let's choose a spanner label called performance. And we'll put it above the columns right here, HP, HP RPM, torque, torque RPM, MPG C, MPG H. Great. So I'll run that. And yeah, there we go. We get performance above those columns. And again, we can do MD here and, you know, make this nice, or like this if you want to do that. Great. So that's what that does. Okay. But again, there's different ways to specify this. You can use quotes like this. You have to use them in all the way across. Or you can use tie select statements, things like starts with. And maybe you know this, maybe you don't. You can put these all in C as well. So if you have multiple tie select expressions, you can put them all together. This seems like the same more typing, but it's really just to drive home the point that you can use tie select as well. There we go. So it's an equivalent table, just using a different way to sort of specify the columns. Great. So next, let's go to, well, let's show an example where we have this table here. And what I've done here is I put the HP column at the front, and the rest of the columns, which I had a spanner over, are way off to the right. What I'm trying to say here is, or we're trying to demonstrate here, is that columns will be gathered together. That's what tab spanner does for you. Okay, it's by default. You can set this to false, but by default, the columns will be gathered together. So the spanner goes over like one set of columns. So if we run this, we'll see a similar but different table. HP is still on the far left, but all these other columns migrated to the left, such that performance now goes over top all of them. Great. So just like we saw with the row groups, tab spanner does the same thing. You can definitely disable this with gather equals false, but more often than not, this will be like the preference. Okay. If the spanner columns which you specify, this is a question here, aren't next to each other, can be moved? Oh yeah, okay, so I guess that was answered as we went on. Great. Tab row group. Okay, so we can add row groups to a GT table. So this is like a manual way of specifying. Okay, I'll get back to that. There's a question here. So I cannot see the outputs you're showing, stuck on line 132. Let's see here. What is about line 132? Okay, I'll just have to say, are you sure you have 132? Also lost audio. No, okay. Hopefully everybody can hear me, but yeah, I will keep talking. Okay, can see and hear you fine. Okay, great, that's great. Okay, so let's go back to tab row group. So this is a more or less manual customized way to add row groups to a GT table. Okay, so instead of using a column which has the row groups, like the labels, we're doing it manually here. So let's try that with GT cars. So we have this GT table right here. Great. And we want to have a row group with just these numbered models of cars. So everything begin with 4 here. Great. So we can do that. Tab row group. We have a label numbered. So this will appear on the row group. And for the rows, we can use a tie select expression as well. We want it because we have, items in the stub. So we can do that. We want to have things which match this pattern here. So if you're not too familiar with these patterns, this means the beginning of the line, we want anything that matches any number at the very beginning. Okay. So let's try this. Okay, so there we are. So we have this row group numbered, and we have 4 rows, the ones that we matched right there. And you might notice that we have other rows here. They're still there, but there's a double line because there's no actual name for these. These are essentially like the others group, a group without a label. It's a little bit sad, but we can actually make it so that we have all the row groups with labels. We just have to use tab row group a few times. So in one case, we can do it based on a column in rows. So we have an HP column, it has values in it. We can specify that powerful cars have HP less than 600, and super powerful cars have horsepower greater than 600. And that should cover all the different rows. Okay, so let's actually run this. I'm gonna run the whole thing so we can see it. There we go. So now we have two row groups. No rows are unnamed. Essentially just two groups, and all the rows that were there previously are in these row groups. Super powerful and powerful, great. But say for instance, you didn't like the order that this was in. You wanted the powerful group above super powerful for whatever reason. We could run this in the opposite order. Another way to do it is to use row group order in the end. And then it takes the groups argument, and we just specify the order of the groups right here. So I'm going to run this. See, now we have the row groups in the order of powerful and super powerful. It's strange because you may have noticed there's an SP here instead of powerful or super powerful, double asterisks on each side. The reason this works is because we can optionally specify an ID for a row group. And this is convenient if you want to use this for things like styling or footnotes, any way you want to reference this sort of thing. And you don't want to put in like a really complicated label into here. This might get pretty complicated if you have HTML, for instance. You can just use an ID and pass that along. By default, the label will become the ID, but you can force your own ID with this. So that's how this all works together. Great. So we'll move on to adding source notes to a table. So it's a citation without any reference to any one part of the table, just a note at the bottom. It's called source note because it's a suggestion you might want to write a note on the source, but it can be used for anything that doesn't have a number or letter attached to it. So let's take a look at this. So we have a almost basic table right here, nothing at the bottom. But if we add tab source note and then add a source note with markdown, we will then see at the bottom, we have this text. The example data set is available in the GT package. And we have it as markdown because we specified that as such. Great. As tab source note, if you need multiple notes, just use another tab source note or as many as you want, like below, just more calls of tab source note. And they will appear down here in the order in which they are called. So that's tab source note. You can use tab source note in conjunction with tab footnote, or you could just use footnotes. It's up to you. Footnote, the footnoting feature is a bit more powerful. It requires some location because it's a referential note. We're going to be tying a note to a specific location in the table. And it'll be indexed and numbered or lettered. You can choose the symbol set. You can choose letters, numbers, anything you want to define in the vector. That'll be used as the marks for the footnotes. Okay, so footnote is the argument where you specify the note itself, like the text. And this is where you want to tie the note to in the table. Okay, as we've seen before, we have all these cells functions. We'll be using that to target different parts of the table. So this list here, running from top to bottom, is roughly the top to bottom in the table. Cells title works on the title or subtitle. Stub head, you can target the table stub head. You can target the column spanners, labels, row groups, cells in the stub, cells in the body, cells in the summary and grand summary. Okay, so let's go to Exhibit and GT, put those together. We get this table. And for our first example here, we want to dynamically add a footnote based on some data. So we want to say this is a banana. It's a really silly footnote, but it's good for demo purposes. So cell's body, it takes in 2 arguments because we want to tie it to a particular cell. In columns, we want to choose the char column, so over here. And the row, the intersect, will be wherever equals banana in the char column. Okay, so it'll be right here. So the note will be tied to this cell right here. So if we run this, we will get the bottom. This is a banana. And the referential label, which is 1 in this case, by default is numbers, is tied to banana. So it just appears at the end of the text. Standard footnote rules apply. If you have multiple on one location, they're separated by commas. The same footnote can be repeated across and it'll have the same number. So nothing surprising here. It just essentially works. And if you don't have multiple footnotes, yeah, use multiple calls of tab footnote. Okay, so we'll get into like styling of cells now with tab style. It's different. Well, I would say it's the same as tab footnote in terms of requiring a location or multiple locations. It's different in that you specify a style rather than a note. But it's strikingly similar because it's location based. So in the style argument, you would supply 1 or more of these. The more part would happen inside of a list. So I'll show you that. There's quite a few examples here because this is pretty important. So I want to show you the before and after with tab style. Okay, this is just like a small version of this example table, 2 columns. Now what we want to do is we want to change the font to Times New Roman. And this is a font on your computer system. So if you have it, it'll work. If you don't have it, it won't work. And the locations you want to apply the styling to are all the cells in the body. If you leave this empty, it just means all. And then all the cells in the column labels. Leaving it empty means all of them. Okay, so let's run this whole thing. And we can see here, yes, we do get Times New Roman everywhere in this table. So if I leave this out, we still have a list there. That's fine. And now we just get it in the columns. Yeah. And that's the same as this right here. You just have 1, the list can go away. There we go. I'll put that back. Great. So that's one thing you do. So basically you can have multiple things here. You can also put a list here. So I'll show you that as we go down here. But first, more on fonts. You can also use a font from the Google Font service, which is kind of nice because you have way more options and it's pretty portable in that, you can use fonts that don't rely on a certain system. The only caveat is that you need to be connected to the internet. But there's ways around this to make this safe if you don't have internet connectivity. So let's for instance, have this. Now we can have tab style. We want to modify the text. But for the font argument, we want to use this Google Font function, which is available in the GT package. We specify a name for the font in that service, and also a weight. This is usually a numbered weight, or it could be bold. And then in this case, we just want to have all the cells in the body of the table, which is basically all the stuff down here and not the column labels. There we go. So let's play around with this a little bit. So the weight, if you put this lower, it'll become a thinner font. We can make this quite heavy with something like 800. Great. They're usually staggered by centuries like this. There we go. I believe the standard, like default, is 400 in most or all cases. And the support really depends on the font. If you're really puzzled with the Google Fonts, like where do you begin? We have this function inside GT called info Google Fonts. There's actually quite a few of these info functions, and I'll show you more of this later. But instead of showing you 1,000 Google Fonts, I just said recommended Google Fonts for GT. These are just a few examples, and you just take these names, put them inside here, and these are the ranges of the different fonts. And it actually shows you whether you have italicized versions of the fonts too, like sort of like real italicized versions, not just slanted versions. So that's what this is. Just a way to show you what's available. There's over 1,000 and it's growing. So might be useful if you want to have this in a, presentation or something like that. But again, it depends on whether you have internet available. Let me show you a few more things. I want to show you how you would change things like the cell fill and the cell text at the same time. So you would do that in a list. So let's take a look at this table right here before we do any styling. Great. So we have this table right here, number and currency. So we use two tab style function calls. In one case, we're going to style based on values in the num column. And in another case, we're going to style based on values in the currency column. And these will be the same styling in the same columns. I'm going to run this whole thing. There we go. And what we're doing here is, we can see in the first statement, cyan for the cell fill, and then bold for the text. And these are numbers greater than 5,000. And we see that that's the case right here. So NAs are skipped because they have no value. And yeah, that's basically a styling based on a value in the same column. Okay, same situation here. All we're doing here is choosing a color for the cell fill. And in this case, it's not a X11 column name. It's actually like a CSS or hexadecimal color. Okay, so color can accept these hex colors, the R names, and also like web color names, if you know what those are. Great, and style italic, that is just the way that the text is styled. Great, in this case, it's where the currency is below 100. So we see that here, anything below 100, not including NA, is styled. So that's tab style. So the important things, multiple locations can be in the list. If you want to target multiple locations, multiple styles can also be in the list. Okay, here's one, again, based on data. We're styling based on values. So this is finance data, S&P 500. We have certain values going all the way down. It's a little bit repetitive and dull, but we can add some color. Say you want to show like situations where the closing price was higher than the opening, we'll make that green. And where the opening or the opening price was greater than the closing price, we'll make that red. So we can do that. There we go. So that's that. So we're basing our styling on values themselves. Great. Okay. So the next function, we're almost at the end of this module. It's a kind of a big one because there's lots of these tab functions. And this is actually a very big function itself. I mentioned this before, tab options. It's got tons and tons of options. It's really hard to go through all these in any workshop. But I'll show you a few key ones. And the documentation for this function has a lot of examples and also a lot of explanations for each of these arguments. The whole idea is that you can modify without using tab style really quickly with a targeted option here. Okay, so let's create a table. This will be sort of like our base table, which will be modified with tab style or tab options. Let's take a look at it in the beginning so we know what we're starting from. So there we go. So now let's modify the table width. So we can set that to 100. What that will do is it will make the table super wide. It will fill the content area to 100%. And it's got this percent helper function here. It's actually the same thing as this. Just prove that. And of course, we can change this so we can have it just go to 80% of the width. So if you stretch this table back and forth, it will, stretch according to like the width of, the entire area. We can modify the whole background area of the table with table background color, and we can put in the color light cyan. So let's do that. As you can see here, we didn't have to do tab style and target all the different locations. We just had to use tab options with this option and specify color, and we can change the background of the whole table. Great. So say you didn't like having letters as the footnote marks. So we have two footnotes here. Or sorry, we didn't like numbers. You can use letters, for instance. There we go. And now we have, you can see A and B are right there. And we can also make a vector as well. We can do this, this, and then we'll see that right there in the table. So lots of options here. So the thing that exposes that is in tab options using footnote dot marks. Yeah. Great. So I'll move on. We can change the padding of the data rows to something that's more dense in case you find the tables are a bit too tall. We can use data row padding. And we're using the PX helper here. This is the same thing as using, just so you know, 5 PX like this. Okay. Great. So it's a bit tighter. You can even make it even more so like that using 3. So tab options, data row dot padding allows you to sort of like make those tall tables a bit less tall when you need that.
Oh,
So
no, what's that?
So if you want to reduce the size of the title and the subtitle text, there's options there that are easy to access. Heading, title, font size. So let's try changing those to small. And we do get small. And we can do things like, change it to some PX size, 12 PX, and this will be, say, 6 PX. So move a little bit here. There we go. Now this is incredibly small. Great. So those are some of the things you do with tab options. There's tons and tons of options. Your friend here is to go to help, tab options, like so. And yeah, we do get all those options, but at least we get some explanations for all these different things. And plenty of examples at the bottom. Just want to state that the way the help system works in GT is it works much the same as any help files in R, except that there's a little small convention here where there's figures, and the figures are tied to examples. So tab 1 will be the first image, tab 2 will be the second, tab 3 the third, so on and so forth. So the examples each have a corresponding image. So it's a good place to start from if you need that. And it's always good to have images of tables to see what the heck is going on. So that is the end of this module. I think a break is in order, like a good 5-minute break at least. I will answer questions in that time. Just want you to have a breather because this was a lot of stuff in the first hour. So I will stop talking right now and I'll look at the questions. Okay, just want everybody to know, if you have to leave now or even the next hour, it's mostly fine. This is being recorded. And again, most of the important information, the key stuff is right at the very beginning. It's intentionally designed to have most of the useful stuff right at the very beginning. So. Okay, we'll resume in about a minute. Okay, so I'm going to continue now from that short break. I think this module will last for the entire, this one and the next one will last for about an hour. So that's good. We'll take a bit of a longer break then, I think, because the last two parts are a bit lightweight in comparison to these two. Okay, so let's move on to formatting your data. So you have columns of data, so it just stands to reason that you may want to format them to some sort of like look that is, better for communication, and not just like, what you have in your tibble or your data frame. So you can actually do that with a line of functions that all begin with FMT. These are the formatter functions. And there are many different types because they both handle different input data and they also they have different expected outputs. So this is, again, nothing surprising, stuff you would see like in Excel or any other places where you would style like your text or numbers. So we have a columns argument with all these functions. So we'll look at format number first. Your data in this case is not the input data, it's actually a GT table. So this happens after you introduce your data frame to GT. You use format number while you have your GT table. Okay, so that's what data means in this case. Columns is the columns you'll be formatting, really. So it'll by default format everything in a column. But you can limit that with the rows argument. Okay, so you can use this to add an expression or some other way to sort of like specify that we just want these rows in these columns to be formatted. Okay, we'll see these in examples. There's some other defaults here. There's lots of arguments. They sort of like, well, I'll explain them all since we're here, because they're common to quite a few of these functions. So decimals is the number of decimal places that are fixed after, if you have like a number which has values after the decimal sign, 2 of them will be preserved in this. Number of significant digits. If you supply a number here, you can supply significant digits to show. Drop trailing zeros and drop trailing decimal mark. This is if you want to truncate the zeros out of your display, like the trailing ones after the decimal place. If you have large numbers, you'll have these grouping separators or these digit separators. Typically that's a comma, but it doesn't matter. Whatever it is, you can enable them or disable them with use seps. So by default, that's true. You want to have those grouping separators. Accounting true or false means you'll use accounting notation. So negative values will be enclosed in parentheses. That's what this does. Scale by is a way to actually scale your number by a certain value. By default, it's 1, essentially no scaling. But you can include any number here, and it will, scale your number by that multiplier. Suffixing is a special option, true or false. What it'll do is it'll do an auto transformation. We have an example coming up to show what that does. Basically, it scales numbers down and then adds a suffix to the end, like M, B, T, for millions, trillions, things like that. So large numbers can be more comfortably read. Pattern is a way to decorate your formatted value. I'll talk about that soon. Basically, you can put any stuff around your formatted value, like any literal text, and it will appear in the end. Sep mark and des mark are your separator and decimal marks. We can switch this to just a period and a comma here to get it in a different style for different locales. Or we can actually just choose a locale here using a locale code, and it'll do that for you. Force sign, all it does is if you have, if you want to show the, say for instance, the plus sign or the positive sign for positive values, you can enable that here. It's really good for things like you want to show percent changes or just changes. Great. Okay, so let's go into some actual examples here. So let's show you this simple table with one column, because you just want to focus on one column for formatting. So there it is without formatting. With formatting, format number on that num column, we get this using the default options. So we get 2 decimal places and we get these commas as grouping separators. Great. Any values are preserved as NAs. Okay, so we can change the options, obviously. So maybe we want 3 decimal places and we don't want those grouping separators. So let's try that. Great. So yeah, 3 decimal places. We still have the zeros there. They're just shown regardless. And you can drop those trailing zeros with that option. True, it's false by default. And now we get this. Great. That may or may not be desired. Sometimes it's good. That's what you get there. So no grouping separators. We don't see any commas here in these large figures. So say you just want to selectively format some of those values in num. So we can do that with row indices, rows 1 to 3. Not always advised in case your rows move around. But if you don't have a stub and rows are not being grouped, they probably won't be moving around. So this is not too bad. So let's just format the first 3 rows with 4 decimal places. And we see that here. The first 3 rows are right here, 4 decimal places. The rest just seem to have 1 decimal place. Great. So say you want to format only the rows of the num column where the values in currency, which is a totally different column, are greater than 30. So we can do that with an expression here. So currency greater than 30. This is a different column, but we're still formatting just a num column. But the rows are dependent on values in another column. Okay, so let's try that. Great. So I put both columns down. Obviously, you need to have them. And there we go. So we see that values where currency are greater than 30. So this one right here, here, and that is it. So these ones right there. So interesting thing to note, we'll get to this later, but this is a question I always get. What if you don't want to show currency? Like in the end, you just want to, format based on currency, but not really show it. You can do calls hide and specify the currency column as being hidden. And there we go. So we still have this formatting based on currency, but we're not showing currency in the end. So that's a very useful trick in case you want to format based on all sorts of things, but you really don't want to show those things that you're basing the formatting on. in the final table. Great. Okay, so lots of other options here. This is formatting based on numbers in the same column. We're choosing one decimal place. We're scaling numbers by 1 in 1,000, so by 0.001. And then we're using the pattern. So what is here is, in the curly braces, this X is the actual formatted value. Anything around that is stuff you're just appending to that. So let's show that. And we see here, these are just for numbers above 500, so they begin here. But we get that scaled down, these scaled down numbers. So they're obviously much smaller, but they have this K to the right of it. Okay, so that's because of format or pattern, I should say. Great. So that's what pattern does. Okay, so that seems like a lot of trouble if you want to scale things down and apply a suffix that indicates what the scaling was. So let's take this country pops data set, which is pretty huge. We're going to reshape it into a small table, which is suitable for display. So let me show you that without too much explanation here. So we get these giant numbers in this table over here. These are different years, and these are different populations for a set of countries. Okay, so what we can do is we can just use suffixing equals true, and it will auto scale and apply a suffix to these values. And we can still control the number of decimal places, like so, like that. So instead of showing giant numbers, we have, it's here, 981 million, 1.1 billion, 1.4 billion. It's a bit easier with these suffixes. So that's what suffixing equals true does. By default, this is false, obviously. But you can turn it on and you can specify which columns you want, which rows you want, and it will do that for you. Okay, so let's talk about locales a little bit. Might be important, maybe not. But you can format numbers based on locales. And what that does is it automatically sets the symbols for the grouping. So these are the, so this is the decimal place right here. It becomes a comma in this French locale. And digit grouping separators for larger numbers become spaces. So it's interesting, as we change this, we might get instead this one right here, which is exactly the same. So there's different variations based on not just the language, but also the country. But if you were to choose a different country here, we would get dot and then comma. If you choose a different country with the same language, we would see a variation of that. In this case, it's a space with a comma for the decimal. So that's what locale does. So if you're not up on locales, but they are, you can do info locales. And there will be a giant table with a listing of all locales. There's lots of them. I think about 800 locales. And these are all of them right here. And it gives you like a preview of what the number looks like and what the different separators are. Really the only difference between them, for at least numbers formatting, are these separators. Okay, and these are what you would use inside locale. Great, so that's all about locales. And most of these formatter functions support the locale argument. So some numbers are integers, and you may always want to keep it as integer. It has better defaults for things which are definitely integers, and it'll do some rounding for you if your numbers start off as decimals. Okay, so let's give one example of how that works. So we have this table right here, single column, the num column. It's obviously, well, you actually can't tell with this type of formatting. But if you were to use format integer, these numbers definitely do not have decimal components to them. They're just integers and they're rounded, according to the usual rules of R, the rounding rules, which is round to even, which is good to know because it might trip you up. So that's what this does. Okay, and just, I don't want to dwell on this too much, but same sorts of options are applied to format integers, except that you don't see any options which are specific to decimals because they're just not there. Okay. That's my one only example for format integer. For scientific notation, say very large or very small values, and it's good to express things in scientific notation. So we have a function just for that, formatter for that. So let's take our beginning table and take a look at it. So I think in this case, we want to switch from like this default formatting, which is got this exponential notation, to scientific notation, which looks different and behaves a little bit differently too. So we're doing two things here. We're actually just formatting the values which are less than 500. So we're just looking at the first few numbers, but these are indeed in scientific notation. An important thing to note here is that anything to the exponent, like 10 to the exponent 0 or not, is just not shown. It's implicit. The guidelines say you shouldn't really show that. It's not great, so they're not shown. So that's why you don't see anything here. You don't see times 10 to the 0. But otherwise, you do see times 10 and then some exponent value. Okay. I got a question here. Does GT play nicely with Shiny? I think it does. You can definitely use it in Shiny apps. There's functions like GT export for using it in Shiny. In my tests, it does seem to work just fine. So give it a whirl. It doesn't behave the same as GT, and you don't have pagination or things like that. But I've seen lots of Shiny apps with GT in it, and they look great to me. Great. Okay, so now we'll go on to something that's very similar to scientific notation. It's actually called engineering notation. Don't know how many of you are familiar with that, but it's similar in that you use times 10 exponential notation, except that it's in groups of 3. The power is in groups of 3. And this is to align with SI, sort of like abbreviations or jumps in values. So let's take a look at that. So we have this initial table here. Num and currency, we're going to apply the formatting to just the num column, in this case, the whole column, to 1 decimal place. Okay, so let's take a look at that. So there we are. So all these don't appear to be in engineering notation, but they are. What we have here on the left side, the numeric part, is any value between 1 and 1000. And then the exponent is, again, in intervals of 3. So -3, +3, and then 6. That's how that works. These are between 1 and 1000, so they don't have times 10 to the 0, just as before. And then, of course, NA values just become NA. They don't change at all. So that is engineering notation. If you need it, you need it. If you don't really even know about it. Percentage units. Okay, so let's look at that with format %. So what this will do is it'll take fractional values by default and make them percentage values. It'll scale them by 100 and then apply the % sign. Pretty simple. If you already have values that are scaled, like that just need the % sign, you could use scale values equals false. That's the key thing there. But otherwise, similar sorts of options: set mark, des mark, pattern, accounting, it's all there. Locale is there. One thing that's added is the placement of the symbol to the right. In some languages, you get the % sign to the left. It can happen. So that's why this is there. Okay, so let's take a look at that. This is not going to be too surprising at all. Essentially, what we have here is a column on the right, fraction of quota, close to 1, sometimes below 1. These look like fractional values. Perfect for format %. So let's apply that function to that column. Yeah, and we simply get percentage values with 1 decimal place right there. So that's what this does. Great. Okay, so I'll move on. Formatting is currency. Okay, so there are lots of currencies in the world, and it's nice if you just supply the currency code. That's what's done here. By default, it's USD, but we can change that. And again, if you don't, just like locales, if you're not up to like all the different currency symbols, there's a function as a reference for that, just info currencies. I will run that. And momentarily in the viewer, we will get this. There we go. So we have a currency code. Most often you'll want to use the 3-letter version. And it shows you like a preview of the same value in that currency multiple times. Also shows you something called exponent. It's kind of a strange name. It just means like how many decimal places is the subunit of that currency. Most often it's 2, sometimes it's 0, sometimes it's 3, occasionally it's 4. But there you go. GT knows about how many decimal places to show the currency. And you can always modify it right there. But by default, it's null because it'll just defer to what the currency has for that, which is kind of nice. You don't have to worry about that sort of thing. So let's do this. You've seen this before. I'll just show it to you again. We have a currency column. We want to change the currency to euros in this case. And there you have it. It just does a simple thing. That's about it. You can change the number of decimal places. If you wanted 4, that is totally not a problem. You can do that. Okay, just by default, it chooses the number of decimal places for you. Good. Okay, so you can do it multiple times for multiple different columns. The num column, for instance, say that's a currency. Say currency is a currency, which makes more sense. Let's run that twice. There you go. So num right there is currency. It has no decimal places in this currency. In this one, it does. Great. So that's all there is to for my currency. All the codes are here. Info functions are your friend sometimes for getting that information. So formatting values as dates. Sometimes you'll have a date or dates and times or just times in your table. And you'll want to simply format that just to make it look a bit nicer or to adhere to some format that you have. So you can do that with format date, at least dates, you can do that. So let's take a look at this table. We have date and time. So they're both, important note, these are both character columns. Date, you might think, why not, it could be in a date format. Currently, this function doesn't support date format. It's kind of strange, but that's something that's going to be worked on because it seems like an obvious thing to address. But for now, you would have dates in ISO 8601 format, which is year, month, day. Okay, as long as you have in that format, this will work. This will format those values. So we're going to format the date column, and then we're going to use date style 3. So what is that? Okay, apparently this is date style 3. But we can look at what those styles are by info date style. Basically, it's a simple way using presets to not complicate things with date and time patterns. Later on, that will be supported. But for now, it's going to be this simple numbered choice, which fulfills a few different common formats. And it's not too bad for now, but this is what we have. And it's pretty good because you don't have to worry about much else except for a number, which is, does simplify things. It's freeing in some way. We can do something a bit more complicated. This is the case where we want to format rows. We do have to do some internal transformations to make sure that this expression works. We have to set these as dates. But once we do that, we could get different date styles depending on some data in the rows. There we go. So this sort of does a switch here at this point. The date style changes. Okay. So that's format date, different date styles. There's a similar one just for time. So you need to have your time expressed as a character column, and it has to be in this format right here. You don't have to include the seconds. It could just be hours and minutes. But that's what this will target. And then you use a time style. So again, this must be, to be unambiguous, this has to be 24-hour time. That's just like the ISO 8601 spec. So let's take a look at this, and then I'll show you another helper function or another info table, which shows you what this means. So we're using time style 3. Again, what is that? Info time style, just run that. There's 5 numbered styles, and they format the time in this way. There you go. The same time rendered in different ways. Time style 3 is, you got hours, minutes, seconds, and then AM, PM. So that's what's shown here. Great. So we can do time style 2. There we go. Nothing surprising there. It just appears as it does here. Great. So that's format time. Okay. Again, you need a character column, has to adhere to that format, which is specified up here. Great. Okay. So we're going to do it twice here. Just another example, just to drive it home. Okay. So we got this table. It's got a bunch of times in the time column. For time greater than 1600, it somehow works. Like, I know this is text, but the way ISO notation works is it sorts alphabetically, like alphanumerically. So strange, but it seems to work. So you can exploit that just by using time less than that. There's probably a more rigorous way to do this with a time class, but this seems to be okay. Great. So next, format date time. So this is just like a combination of both. So you have to have like your character vector in this format, like so. But if you have it like that, you can choose a date style that's independent of the time style. It'll just put them both together. So that's kind of interesting. So we can do this just to show the input table. That's a date time column. So we have hours and minutes. We don't have seconds here, but we can choose date style 5 for the date part, for the time part, time style 3. And they go together. They're linked together by space. There's no way to choose the separator between the date and time part, unfortunately, at this point, but that may be an option in the future. But it's not bad. It's not bad. You can choose date and time style separately. Okay, so we'll get past all the dates and times now. We'll move towards this. Formatting your text as markdown text. So you may have some free-form text in your table, and it may have markdown in it. And then if you use this format markdown function on those columns, it will transform that markdown to the target output format. So last time I ran this, it didn't work inside Cloud for some strange reason. I'm not sure why. There's some sort of, oh, now it does work. Okay, brilliant. Okay. Because before it did not. It was very vexing. Okay, so I'm just going to run this whole thing. Okay, what I'm trying to do is I'm just creating these like length 1 vectors of different markdown text. Then I'm using dplyr tribble to create a table with that markdown text. So it looks kind of weird here because it's kind of big. If you run this into GT, we get this. So this is like your raw markdown text right here in different cells of the GT table. Okay, columns are just silly, markdown and MD. So if you were to run down format markdown on all columns using columns equals everything, we would get the markdown being transformed to markdown. So this is kind of nice because we can, make a text table, lay things out. We might remove these borders and just lay out things in a table. And it's quite nice. Things like links work. So if I were to click this, I'd be taken away. Same here. Yeah, this is not bad. And we can change the table width here to make this a bit more appealing to look at. There we go. That's format markdown. In terms of options, you don't have much. Essentially, it is just this stuff right here. Columns, rows, that is that. Okay. So NA values in your table, you may have seen quite a few of those. Example has 1 per column, I believe. You can process those separately, replace the missing text, the NA text, with something else. So essentially what format missing will do is it'll, in the different columns you have, and you can even target rows if you like, you can replace that NA text. And you don't have to exactly specify the NA cells. You just say all these columns, just replace the NA text with this. Okay, so it'll just skip everything which is not NA and just focus on the NAs. So let's do that. So we have this input table here. As you can see, NAs all the way across. Well, actually, this factor column doesn't have NAs, but the rest of them do. Okay, so let's address that. Columns 1 to 2. So these two columns, we can always use indices if we wanted to. We'll say the missing text will be replaced with the text called missing. And columns 4 to 7, these ones right here, will have their NA values replaced with nothing. Okay, so let's see that in action. Great, there we have it. Missing, missing, nothing here has changed, but rows 4 or 7, nothing, 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 nothing. This is not useful. By default, I don't really show it, but I do want to show it to you. If you just use format missing on columns equals everything, I just want to show you the default look. It's essentially an M dash in every single one of these right here. So you could do an M dash with that. If you were to use, say, for instance, 2 dashes, that maps to an N dash, which is a slightly smaller dash. This is a bit esoteric, but just good to know in case you want to have that exact. But by default, it's this right there, which you don't have to specify. Here we go. Okay, I will take this out. Okay, run missing. So you can use that independent of the other formatter functions and just take care of your NA values if you want to format those differently. Okay, this one's a pretty big and somewhat complicated function, I have to admit, because it relies on functions which are not in GT to work nicely. But we do have examples both here and also in the different help files inside the GT package. So data color, what it does is it sets data cell colors using a palette or a color function. Okay, so let's take a look at that. So we can add color to data cells based on their values. So these can both be numeric values and also text values, because text values can become like factors. Let's take a look at country pops, for instance. So let's run this code right here just to get that, to make a GT table. So we have here is country repeated all the way down, different years, and the population value. Great. So for this application of data color, we want to color the population column, which is this numeric one right here, by their values. Okay. So in colors, we're actually supplying another function, and it has its own arguments in there. So again, I said this is pretty complicated. So we can go to data color. This is just for future reference if you need to use this. It has examples in here, and it tells you which functions that could be used inside that colors argument. And it tells you how and why you would use them. Okay, a little complicated. Thank goodness there's examples here and with working code. Otherwise, a little bit tough to start. So always start with an example is my advice here. But at any rate, we're using call numeric because we want to scale, not scale, but color values based on their numeric value. This palette here is essentially different colors are going to move through, almost like a gradient, like these are gradient steps. And the domain is where the first color starts and where the last color ends. Okay, this is from 2 million to 4 million. Not sure why I wrote it in this way, but I did. But let's take a look at this. Okay, so we see values sort of starting from an orangey color, ending in a greenish color. That's because these values, they don't start anywhere near the domain values here. If you were to do something like this, like 2.6, and end this off at more like 3.1, we would probably get the reds and the blues, okay, because the data is closer to the boundaries there, and they are. And a key thing to note here is that GT will automatically switch the text color to achieve maximum contrast for you. So you don't have to worry about, flipping colors in the end manually. It'll do that for you, which is kind of cool. So let's take another table and apply some more coloring. So we'll take this pizza place data set, we're going to work it up a bit to make it smaller. Let's take a look at the table before data color. So we have this. And I think the goal in this data color call is to add color to the sold column and to the income column of that table. And this will be done independently of each other. Like the domain in this case will be null, which means that for each of these columns, the domain will be the range of data. So it'll be the min and max of each column. Okay. A more complicated thing here is that instead of we're using call numeric again, we're going to specify a palette as a palette that's available in this Palettier package. Okay, if we were just to run this little bit of code here, it would give you a palette right here. So just a bit of some basics on what the Palettier package is. It's another package which contains lots and lots of other color palettes. You can take a look at their GitHub page and it'll show you, like it'll give you a preview of what all the different palettes which are available. But it's kind of nice because you can just use one of their palettes. You don't have to dream up something. And they basically combine palettes from lots of different packages into one package. So in this case, we're getting the red material palette from the GG-SCI package, which is supported inside Palettier. We have to do this as character thing because palette in the scales call numeric function requires a character vector. So we can't have this colors object. We have to have actually this. Okay, so that's why we do this. It's a bit of a sort of a correction we have to do. But if we do all this and we set the domain to null, we're going to see those red colors and they're scaled to values. There we go. So each of these is done independently. And there we go. It's based on red material. Great. So that is data color. It's a bit of a tough nut to crack, but again, the help is very important here. I have the same examples inside this help. And again, those images correspond to these bits of code. Okay, so I want to take a short break just to sum up. Lots of formatter functions available in the GT package. The plan is to add more later on and to expand upon these and make them better. But numeric values can be formatted format number, format scientific, format %, so on and so forth. You can do dates and times as well. Markdown text has its own function. It's very simple. Missing values can be formatted. Data color, you can use that to color cells based on values. And a number of info functions are pretty instructive in that they can provide you with things like locale codes, currency codes, date and time styles. And I'm not going to run it, but there's actually one for, well, I'll run it in the break. It's info Palettier for a number of different color palettes. Okay. So basically you use, AW tools, : and then the name of the color palette. So this could be useful if you want to have your data colored inside of cells. So let's take another 5-minute break. Come back here. Well, maybe at in 5 minutes. I'll keep my my microphone on mute and I'll answer any questions which are in the chat. I'll catch up on those. See you in a bit. Okay, I suppose I'll carry on right now. And I will move on to the fourth module in this workshop, which is called Modify Columns. So this one uses a function family that all begins with calls underscore. So calls align, calls label, calls with, a bunch more with merging. So these all are common in that they modify based on entire columns. So it includes alignment of data in columns, hiding columns from view, relabeling the column labels, and merging two columns together in special ways. As you see, there's a few variants there for column merging. Yeah, so quite a bit there. So let's give the most simple of these, which is called calls align. So this allows you to set the alignment of columns. So just GT will automatically align columns based on their content. If you have numeric values, they're typically aligned to the right. If you have text columns like character, they are aligned to the left. I think dates are also aligned to the right, depending on whether they're formatted or not. But there's some default alignments right at the very beginning. There's some auto alignment. And but you can change things. You could select one or more columns and change the alignment. So let's try that. Let's try that with this table over here. We'll make a simple version of the country pops table and feed that into GT by the GT function. And we see here we have things aligned as they are often seen. Mongolia, or which is text, will be all to the left. Year and population, because they're numbers, are aligned to the right. So let's actually do something different. Let's change the alignment of population and align it to the left with calls align. So running that, we do now get this. It's a little hard to see, but we do get this alignment to the left now. You sort of see that these are not aligned the same. So that's what that does. Calls align will align to the left. It doesn't have a rows argument. So when you're aligning the whole column, and that's kind of it. But it includes the column label as well. That also gets aligned. Great. So that is all that I can really say about calls align. It's pretty simple. It's a good way to sort of get started in this module. Calls label is a bit more complicated, but not by much. But what it allows you to do is it allows you to relabel one or more columns. See, what happens is when you get a table into GT, the labels are the column names of the data you passed in. But you can change the labels, and they can be any sort of fancy label you want, which are not really great for data tables, but they're great for things that you're presenting, like GT tables. So the signature is a bit weird. We have data coming in, we have ... Okay, so we've got to figure out what to put in that ... Okay, in this case, it's really just a list of the column name and then the labels you want to use instead of the column name. So these column names will be there. They're like the names of the variables or the columns, but the labels can change. Okay, so that's what we're doing here. So incoming is this table over here. Country underscore name, year, population, all lowercase. We want to change it to just name, title case, year, population, like so. Great. So now we have it. There we go. Name, year, population. So this is the construction we want. We want to have column name, and then the column label after that. Just have a list all the way down. So that's calls label. There's more we can do. Because we're actually adding new text, we can use these helper functions like MD to interpret this as markdown text. So you want to have your labels bolded in some way, you can do that. There we go. So we have this. This is the beginning table. So now you want to have name, year, population, all bolded. There, so we can do that. And we can mix and match, do this as well. Scrolling up, we got that. So of course we do that with tab style, take any of these and apply bold, but this is just a simple way to do it. You're going to rename the columns anyways. You have a shot to just like change it right here. So that's the flexibility that you have with calls label. Great. Calls width is similar, but it's actually even more complicated, even though the signature looks the same as calls label. We just have ... What we're doing here is we're trying to specify the widths of the columns. By default, the widths will be specified, or the widths will be set based on the output format, what the default is. For HTML, it's usually based on the content. It fits to content. LaTeX is kind of the same. RTF is kind of like not the same. It's equal widths all the way across. But regardless, you could set the widths explicitly with calls width. So let's try that. And again, it's a bit more complicated because you have to use this formula syntax. So what you do on the left side is you specify the column. On the right side, you specify the width. But on the left side, you can do things like select multiple columns and then set the width for that. Right here, you can use these select helpers. And then for anything that's not captured, you can use everything. That means in this situation, everything else that's not caught by these, and set that width to 60. Okay, so let's see the before and then after. So this is the before. So standard widths that are applied based on the width of the content. Now let's use this. Okay, so now we get num 150 pixels wide. It's really hard to get a sense for what the pixels are, but we can at least see things that end with, ends with R, which is char, is less than this. And then date, anything that starts with date. These two things are super wide, 200 pixels. And then everything else, which is the row column, is 60 pixels wide. So we can play with this and then rerun it again. It's going to do it this way. So we don't scroll down. Great. So you can use these helper functions like px to specify pixels. If you set all these as pixels, and you set all the columns, you could do things that you normally couldn't do, like set impossibly small widths, and it's actually accepted. It's a bit strange, but it might be good in some situations where you just want to color, like the column itself, and you don't want to have any content in there. There's some application for this, is what I'm saying. But normally you want to have, you may want to set this just sort of manually based on your own aesthetics. You can do it like that with calls width. So something totally different is moving columns around. There's a few functions for this. We'll focus on just one. It's calls move. With this function, you can move one or more columns to different locations in your GT table. So this is nice if you don't want to move things around in your, your table coming in. You just want to move them in the end, like in your GT table, which is kind of convenient because you can experiment and play around with positionings of columns if need be. So what you would do is you would just choose the columns that you want to move, and you specify the column which those columns should be placed after. Okay, so let's try that. Let's take country pops, make a GT table from it. Okay, so we have country name, year, and population in that order. But we actually want to move population to be after country name. So we're switching positions of year and population. So let's give that a whirl. There you have it. So population moved over. So this is kind of nice. If you're moving columns around, sort of like a thing to consider is if you're actually referencing columns by their index, the index is based on the input data, right? That will never change. So it's good, but it's confusing. The better thing to do is to refer to columns by their names. And that's, it will lead to less confusion especially when you move columns around or using spanners and columns do move. You don't have to worry about like the index shifting on you. So that is calls move. And there's two other functions to do that. There's also, if I just do like calls move here, you have the shorthand functions, calls move to end and calls move to start. Just sort of a modification on calls move if you just want to move one or more columns to the beginning or to the very end. Okay, but certainly calls move is the most flexible of those functions. Say you want to just hide some columns. They're useful for you for some reason while you're styling tables, for instance, but you don't want to show them in the end. You can hide them with calls hide. So let's take a look at that. So we got this table here. It's in GT. Let's take a look at that. So it's a great looking table. We got some redundant data though. Country code 2, country code 3. We don't really need those. We might use them in the API to do one or more things, say in an expression, but we don't really want to show them in the end. So we can just hide those. Calls hide is what you need. Refer to the columns by name, put them in C. And then if you run this whole thing, we do see that, well, we don't see those columns essentially. We see country name, year, and population. So that's what calls hide does for you. Okay, so here's a more practical example of that. So we have this, and we want to basically use a footnote and say population was above 3 million on a certain year, right here, based on population actually being above 3 million. But we don't want to show the population or country code 3 columns for that matter. The cool thing is we can put calls hide before or after. The location, I mean, where you put this expression, this little statement, doesn't really matter. Sorry, I'm just gonna run this whole thing. There we go. And we can see here the note was correctly applied to the years where the population was above 3 million. The population column is gone. And that's what calls hide did for us. So we can shift this to a location below as well, like so. Or link it together like this. Just to prove to you that it doesn't really matter the order here. There we go. Same sort of thing. Okay. Again, because GT will essentially take all these as instructions, the order only sometimes matter when you're adding content or things like that. But in most cases, the order doesn't really matter. So calls merge range. So this is part of a set of calls merge functions. And what they allow you to do is take two columns, put them together as one column, and then it will essentially delete the second column or hide it, really. Okay, so calls merge range. This is useful if you have like a column which has values at the beginning of a range, and then another column which is values at the end of a range. You want to combine them together. Okay, so let's take a look at that. So we have two columns. Not really a range. I guess it could be construed as a range. MPG-C, MPG-H. We want to combine them together. Okay, so let's do that. Calls merge range. Then automatically puts a separator in, which is the n dash, which is nice. The only problem is the column that's preserved is the first column, MPG-C. And because the content has changed, just a note, you may want to change the label. So in this case, just to MPG, like so. There we go. That's what calls merge range does for you. There's a few more variants of this, like calls merge unsert. With this, you can merge two columns to a value and uncertainty column. Okay, and my example is not ideal for this because I'm using Exhibit and doesn't really contain any scientific data in it. It just contains sort of like play values. But let's pretend just for a minute, because these are the values and these are the uncertainties, which are plus or minus the same value. Okay. So let's do a formatting first. One of the cool things about this is you can format the numbers independently and then merge them together. So you can format your currency or this column differently than the num column, and then bring them together. So let's do calls merge unsert, and then we'll relabel the one column that's remaining to a different name. Okay, so we have it there. It's a bit silly what we have here, but I just want to drive home the point that this is how it works. Important notes are that if the uncertainty value is NA, it just won't be shown. The value will just be there. If you have an NA value in the first column, which is the value one, it'll always be NA no matter what's in the uncertainty. So those are two things which work in this particular function. So that's how this works. So if you have uncertainty values that are tied to values, this is how you can bring them together into like one single column. So you have, this is the final variant of calls merge. So you have a number, n column, like a count column, and then a percentage column. You can do the same sort of thing. You can use calls merge unsert. Call n will be the n column. Call PCT will be the percentage column. And you can bring them together like this. So it'd be like 12, and then in parentheses, you would have some percentage value. Great. So let's get to a table, which is right before that. So it'll be right here. Great. Scroll down a bit. But we can see here in this small bit of the table, we have an n column, which is a count. And we have this frac value, which has now become a percentage. So we can combine these together. So we formatted these independently, but now we're going to bring them together. Okay, so we'll do that with calls merge n%. And then I'm just going to do a bunch of other things here because I just made a full table here, but we'll still see the results of that. Okay, let's scroll down. So now we have this n column. And now we have, yeah, exactly this count and a percentage in there, which is nice. There's a few more tricks in here too, which are important while I'm here. I've inserted line breaks in some of my column labels. This is pretty useful if you want to save some horizontal space. You could do it one of two ways. One way is with BR. Okay, that inserts a line break. Another way, and this is very hard to remember, but it works if you have markdown text, is you can use two spaces and then this slash, this backslash, and then n, like a line break, a line, yeah, sort of like new line symbol. So those both work. They have to use MD for it to work, but if you do have that, you'll have line breaks. So there's a 2-in-1 thing, how to do this formatting plus line breaks. So we did 3 places right here. Great. So now I want to show you just one more thing in terms of columns merging, the general function calls merge. What you do here is you can merge 2 or more columns to a single column. Okay, so a bit more complicated, but by default, you choose your columns in the order you want to merge them in. And then you hide everything but the first column. That's what this does. And then the pattern here is kind of like this. Well, it's hard to explain. There's basically going to be spaces for each of these. Okay, so let's take a look. Let's have this table come in. So we have this S&P 500 table. It's only got a few rows, but we have open, high, low, and close. We want to merge a few columns together. In this case, we want open and close to be together. This pattern here is what we want. Open first, then close. And then want low and high together. And then we want them to be the same sort of formatting, one basically a hyphen between them. And then we want to relabel the columns to be open, close, low, high. So let's take a look at that. Great, so that's what we have here. So those columns came together. Certain 2 columns were hidden, and we have these merged columns together now. Great. So that's all these calls functions inside GT. Just to break that down, summarize, calls align, we'll focus on alignment. Column labels, you can set those with calls label. Widths of columns, you can precisely size them with calls width. And this is actually wrong because this works on all outputs now. It's a recent change. It works on HTML, LaTeX, and RTF. Okay, you can move columns around with calls move, hide columns with calls hide. You can create range values with calls merge range, values with uncertainties with calls merge uncert, and something that is more custom is calls merge and using a pattern for the merging. Great. So that is that. Maybe we'll take another 5-minute break if that's okay with everybody. The last two are shorter than all of the previous modules. This is focusing on 2 functions. This has a few nice functions to use, but not super necessary, more for display and aesthetics. So if you had to leave, this is not a bad place to leave if you had to. But if you stay, it'll be great because you'll learn about some neat things. Yeah, but let's take a 5-minute breather and we'll resume shortly. Okay, I think we'll resume. And as I said before, there's not too much in these final two modules. Well, certainly summary rows is pretty important, but table option functions, this is more like a grab bag of useful options, which are in a separate set of functions, which sort of like makes the most common options easier to find. So definitely this is almost like the sugar on top, and this is kind of like important, but yet brief. So let's get going. We might end up a bit early, which is altogether not a bad thing, because we got through all the content. But let's talk about summary rows and grand summary rows in GT. So these are two functions that will add rows to a GT table. So the key thing is that summary rows is groupwise, in that if you have row groups, the summaries will be generated based on those groups. Grand summary rows operate across all groups, so it takes the data all together across a table, whether there's groups or not. Okay, so that's the difference between these two functions. So again, the function, it's one of the more complicated ones in GT, but you can use help. Summary rows. Go to the help. There's working examples. There's figures as well. Well, example singular, just one example, but it does at least show like, you know, all the key things and provide you some output. So it's a good starting place actually, because it's a bit complicated. You have to specify functions, and what you supply here is a bit complex. But we'll get through this. Okay, so let's take a look at this right now. So we have this table, we have a stub and row groups as well. So group A and group B. We have some numeric values in num and currency. We want to aggregate with those. In this case, we just want to aggregate on num, but we want to work across the two groups, group A and group B. We have a little note here. It says true will target all groups. So we can just put true there if you wanted to. The more complicated thing is this functions value they supply here. So what you're doing here is you're providing a list of one-sided R formulas. In this case, we want to sum everything that is in that column, in that group, and that's it. And this is the label right here that would appear in the stub, this sum. Let's make that a little bit different, like capitals, to show you that it's actually affected in the table. So let's actually run this. Okay, so we can see it right now. We generated one row because we have one expression in this functions list, right? We're operating just on num. Everything else here in this row, this new row, has got nothing. So by default, it will change this missing text to be an M dash. Okay. So we get the sum right here. Great. And it uses the default formatting of what you're putting in. Okay, good. That's good. That's a good start. So let's extend this a bit by formatting num values and their summary values. Let's add some minimum and maximum values, the summary rows as well. So we'll add more summary rows and we'll, well, that's basically it. Okay, so we're going to format the numbers first to 1 decimal place. Oh, sorry, it's below. So we have this. So we haven't done the summary row yet because we just focused on formatting the actual num column to 1 decimal place. Great. So we've done that. Now we're going to add summary rows. Same sort of expression. We'll add more rows, one for min, one for max, in addition to sum. But in this formatter argument, we'll add format number. And then below that, we'll add different arguments for format number. Decimals equals to 1. And this will match what we have above. So what we'll get will be summary rows where the aggregate values match the formatting of the values that it's aggregating. So let's run this. I'm going to do it like that, then move down. Yeah, and what we get here is just the sum column with 3 rows per group. Move down and see that. I have to scroll that more. There we go. But the key thing here is that we formatted the values in the summary rows the same as the values above, which is kind of cool. But requires some more planning. So, but that's how we do it. Okay, so we can do it separately we can have multiple semi-row statements like this and still fill in the same rows. As long as you use the same labels here, the rows will be filled in, like the cells will be filled in without creating new rows. So you may think that this will create new rows, but it'll do its best based on like, what's already available in the stub. So let's run this. We're gonna create semi-rows for both the currency column and for the num column, working across all groups. Let's scroll down to the output. So we have this right here. So we have the same labels, but we have different aggregates here. We specified them in different ways because we wanted to format them differently. That's why we had to split into two different semi-rows calls. But we did it and it looks nice. We added one more thing. We've replaced the missing text with an empty string, so we don't have those hyphens or those em dashes all the way through. We did that right here. Missing text equals nothing at all. So that's great. So that's how this looks. So group-wise summaries across two groups, two different columns, and the rest is sort of omitted. Okay, let's move down. So I have another example here. This is just a maybe more complex example. Let's take a look at the starting bit right here. Great. In this case, we have very similar data. These are all like pretty much the same format. So we could format all those columns together. We don't have any NA values, so we don't have to do like NA RM equals true in this case. If we did have NA values and we didn't include that, it would not create anything for you. It would just be NA, which is a little bit dangerous. So sometimes you may just want to put this in as just to be a little bit safe. But sometimes you really don't want that. So anyways, just be mindful of that we do need to include that if there are NA values there. But at any rate, these are all currency values. So we're going to format them with the default formatting in both cases. And then, yeah, this is what we get right here. Well, actually, we got to run the code. Let's do that. Great. So scroll down. We see that they're formatted with their defaults, both the same. And it looks pretty good. There we go. Scroll this way. Min, max, average. Great. So grand summary rows. So those are group-wise summary rows. If we want grand summary rows, we use that function. Interface is very similar. We don't have a groups argument because in this case, we're disregarding groups, but everything else is the same. So let's actually take a look at some examples of that. So let's take this S&P 500 table with some formatting applied. Take a look at that, move down. So two groups. But as I said before, grand summary rows ignores the groups. It just takes all the data, regardless of group, and aggregates that way. So let's run all this code and see how it looks. So there's a group right there. There's a group right here. Scroll down some more. We have this double line because this doesn't belong to any group. It belongs to essentially the whole table. We're aggregating all the rows. So min, max, average, like so. And just so you know, you could have both group-wise summary rows and grand summary rows together in one table. I don't have an example of that here, but it's certainly possible. I think it's in one of the articles in the GT repo. If you look in the package down reference site, there's an example of that. But yeah, give it a try. Again, work from the examples here. There's also one for grand summary rows. And it has its own help article and its own example for that. Sort of see that right there. Great. Very useful to work from the examples. Great. So this is a very short module, but nothing wrong with that. Just focuses on two functions, summary rows and grand summary rows. Again, I admit they're not easy to use. You're doing a lot. You're adding new rows. So don't feel bad about using the help at all. It's actually a good thing. I never get it right the first time. I always have to jog my memory. So definitely do that. Again, you might call these functions several times to build up summary rows. Use the same labels to line up entries across columns. That's the key thing. Okay. So that is that for summary rows. Let's move on to something light and much simpler, I would hope. It's the opt function family. So what this does is it just provides an easy way to set up commonly used table options without having to use tab options. So a lot of these come from tab options, and maybe there's a few more things involved, but think of these as more like macros for tab options, easy ways to set or access things that are a bit hard to find or maybe just a bit difficult. Okay, and we're using these again just for some of our examples, and we've seen this before. So say, for instance, you want to modify the footnote marks you're using in a table. You have some footnotes declared. You're not really happy with just numbers. First, you want to change it up. Instead of using tab options, and then like the option that is somewhere there, you can use opt footnote marks. It's just an alias for that. So let's take a look at this data set right here. I'm just going to show you the whole thing before we use the final function we want to look at. So we have this right here, this table right here. So the key thing to note here, sorry, it's a little hard to scroll. Let's start here. We have 1 and 2 as the footnote marks there. And if we scroll this table right here, we see 1, 2, and 3 at the bottom. Okay, the third footnote's there. But we could change the marks to this. Standard, I don't know what that is, but apparently what that is an alias for a vector of symbols that you can use. Okay, again, help is good. So help opt footnote marks. Okay, it explains everything. And it actually explains what the different sort of standard sets are, which is good. Gives examples. So there you go. So it's nice in that you could like, just concentrate on footnote marks and have a separate help article for just that, because it's quite a bit there. And just to have it all in like tab options, which already has like tons of everything in it. It's nice to have a separate function and article just for the one thing that you want to do. So that's what this does. Okay, and just one look at the table, we can see right here, asterisk, dagger, and there's presumably a third symbol down here, double dagger. There we go. Good. Okay, so opt row striping. Here's an option to add or remove row striping. These are sometimes referred to as zebra stripes. So you can say true or false. Do you want the striping or not? Okay. So let's go for the striping. So I'm just going to run this whole thing. Okay. Because before adding this, there would be no striping. But if we do add that, we do see sort of these subtle stripes. It may not come across, it'll either come across well or not in the Zoom video, but these two rows have a subtle darker color. They're not shown in the summary rows. They're just for the body rows, but that's what we see here. So yeah, that's row striping. Just a simple option if you want that. Some people do, some people don't. The default is not, but this is a simple way to activate that. So here's another one, opt align table header. This is just a simple option to align the table header. By default, the title and subtitle, they're center aligned. You may want it to be left aligned. Let's look at it before, like that. Top is the key thing here. So you want it left aligned. Let's do it like that. This is a pretty smart look actually. So it looks pretty good that way. Could use a bit of space. You can style it so like, there's a bit of space here. You can also add a space here, I believe. This may or may not work. Let's run it again. Oh, I ran it wrong. Here we go. There you go. That did not work. Just the nature of HTML is it tends to trim away white space. If you really want that, it takes a bit more difficulty. You can always like style the header and add an indent to it if you want a little bit of space there. So that's how that works. And you can also do right. Okay, we'll scroll up. There we go. It's on the right side. Good. So opt to all caps. This is a very opinionated option. It allows you to use all capitals in select table locations. Really, this is around the boundaries, around the body. So you can choose the locations that this applies to. You can choose all caps or not. One of those things which is harder to describe than it is to show. So let's actually just take a look at the before and after. Okay, so this is the before. Now let's take a look at the after when applying this function. So now we see here that the column labels are a little bit smaller. They're set in all caps and they're boldened, like so. Okay, this may be good, maybe what you want. It sort of apes the look of some other like tables, which are pretty popular, in which the less important information, like not the body text, is sort of like set off differently. So opt table lines. So this is an option to set table lines to different extents. So you may want to have all the table lines there initially. You may want to have no table lines and then just do it yourself, like DIY it, like set the lines you want or remove the lines you don't want. Or go back to the default case in case you did both. So let's take a look at this. So here's a table. There we go. That's our standard table with standard lines. If we really do this, the default is to add all the table lines possible in the table. So now we have these vertical lines. We have just a line around the table. They're everywhere. But you can set this to, I believe, none is the one. We have no lines. We do it like this. Great. And now we have no table lines. Okay. So it's a bit strange, but you may have it, you just have a text table and you want to remove the column labels. You just want to have some text in different locations. This might fit the bill, or you might want to start from this and just add table lines with borders and things like that. So it's totally up to you how you use this. It's useful in some cases. Opt table outline. So this is like just focusing on the outline, but we can style it. So this is a strange one, but sometimes you just want to have like an outline around the table. So this allows you to do that. So let's see the before. There we go. We don't have an outline around the table. This is a top line, but there's no lines to left or right. So let's use this. Great. Now we can sort of see, if you look very carefully, there's a left and right line. There's a table outline all the way around the table of consistent width. Which we can change. We can change the color to, say, for instance, red. And if you were to do width, we can do that as well. We can use the pixels helper to make it big. So let's see the table now. So now we have this chunky red outline around this whole table. This might be good. This might be not so good, but we can even choose a style, have like things like different types of lines like dotted or dashed. Just in case you need it, it's there. Okay, so that's opt table outline. Okay, now I'll move down to opt table font. So this is a way to provide a font for the entire table. So you just want to start with a different font than what your the defaults are. You can set that with opt table font. So you can define a custom font for the entire table. Let's take a look at how this looks. So before, it's like this. Great, that's a little bit of it. So now inside the font argument, we can provide a list of fonts. One of them could be a Google font. And there's different options in here for size. And these are fallbacks in case, say you're offline or you spelled this wrong. It'll choose Cochin or serif instead as fallbacks. Great. It's Meriwether because it's spelled right. If you misspell it, for instance, it won't choke on you, but it'll choose the next font, which is Cochin right here. So that's how that works. So you can set inside your font a list of fonts, which is quite nice. Again, you may misspell this or you don't have internet and you still want a table to show with some sort of font. You can choose another one. Okay. So a bit more on table fonts. You can choose local fonts as well. You may have Helvetica Neue. You may have Segoy UI. If not, we have this like vector prepared for you of default fonts right there. And this is actually what's used on the GT table, like, without using opt table font. It's just this list right here. So if you have, if you're on an Apple system, it'll use that font. If not, it'll use this one. If you don't have that, it'll just keep going until it gets to the more general fonts. But you can mix and match. You can set these before this default font list. So let's try to use Helvetica Neue. There we go. A little hard to see. It looks just like Helvetica, but it is like the slight variant in that, and it's being used here and here as well. So that's what opt table font can do for you. It allows you to set the font without having to use tab style, and reaching to lots of different locations and setting up font that way. You can do that in conjunction with this, but this is just a nice, easy way to set up the default font for the table. This one is a bit more complex. It's for the HTML lovers out there. Probably won't get much play, but what I'm trying to offer here is a way to change the CSS for a table. Again, this is HTML specific. If you're using Shiny, this is great. This allows you to like do things you can't really do in tab style. There's options which are not available. It's a bit complicated. There's a help article. Basically, if you know CSS or can figure it out, it's not too bad. So here's an initial table right here. It's basically this right here. We set an ID for the table of 1. We have to use that here to target this table and nothing else, in case there's more GT tables on the page. Okay, that's why we set an ID, explicit ID for the table. And then we can find different, classes or different IDs. You would, search around the table for, in the dev tools and in a browser and see what the different properties of different, elements or like CSS selectors are, and we can change them right here. It's really kind of cool. This is for the entire GT table. This is for any row. This is for any column heading. You really have to poke around to find these, but if you do, you can change these properties and do things you normally can't do. So really the sky's the limit here. So let's actually run this whole thing. Yeah, so what I've done here is I've changed the background color of the whole table to sky blue. Apparently this is just like not including this. But the row, we changed the padding very precisely, top and bottom. 20 px on the top, 30 px on the bottom. We changed the column heading. We changed that to be centered and to be important, to override anything else. So these are some of the very custom things you can do with this opt CSS function. Again, it only concerns you if you're doing Shiny and you really want to have a look or change something in the GT table, which you can't really do in the API, like, with other functions. So this wraps up the entire workshop. Just want to say, like, opt functions are great. They typically take the place of tab options, and make it easier, and provide help articles for those. So that is about it. I don't see any more questions. There's a general question: has anyone used this with Power BI? Let me know if you have. I'm curious about that, Ashley. Okay, I got a question here. Sorry, go ahead.
Sorry, Rich, let's go through the questions, but I was just going to thank you formally. But yes, if there are questions, just please do ask now, and then we'll just give a bit of time for that.
Yeah, so I have a few here. So are there any restrictions, pitfalls, or best practices on how functions should be called in sequence? Yeah, there's only a few functions which have an interaction where the order kind of matters. Things where you may be reordering columns, the order that you call those in, you may have consecutive reorderings. So that's important. If you're setting, for instance, row groups with tab row group, the order in which you call that is important. It affects, the order that the groups are made in. Things like adding source notes, the order in which you specify those are the order that they appear. Footnotes is largely independent because the orders depend on the index, depending on the index of like the cells. So as independent of like the calling. That is pretty much it. Just I think it's just those few things where you add content. Summary rows, that doesn't really affect the order, doesn't really matter there. So that I hope that somewhat answers it and gives you some insight about that. That may be it.
Great, thank you, Rich.
You're welcome.
Just a really, really big thank you, Rich. I mean,
Yeah.
you flowed through that like a river, and I'm sure it was really nice that that you did that for us. A big round of applause. I'm going to just encourage people to complete the survey, and I'm going to stop the recording now. And thanks all the participants. I know not everybody could stay till right at the end, but Rich has really kind of modularized the delivery so that the bulk of it was in the first 2 hours. So thank you, everybody. And I wish you a very good, pleasant evening. And thank you, Rich, again for a magnificent workshop.
Well, thanks for inviting me. And anytime you want to do this, I'll be here.
Yeah, we'll look forward to it, Rich. Thanks very much indeed. Bye-bye.